So now we're going to take what we know about vertex form and apply it to translations or transformations of quadratic functions. So what I'm going to start by doing is on each of these four graphs, I'm going to plot the parent function, which is just y equals x squared. Okay, so what I want you to do now is in a different color, I would like you to, in your calculator, put the function that you see. So for the first one, up here, I want you to plug in x squared plus 5 in your calculator. Then what I want you to do is go to your table and plot those points. So I'm going to do the same thing, and these are the following points that I got. I got 0, 5. I got 1, 6, and I got -1, 6. So this is my, let's draw that a little curvier. This is my quadratic function. So what happened? So since what happened pretty much is the only thing that the red graph did was shift up. So this 5 out here like this is a shift of up 5. Okay, our next one. So number 2. Again, plug that in your calculator, watch the parentheses, and see what happens. So when I go to my table, I get the point 1, 2, 3, 0, 4, 1, and 2, 1. Then I also get 1, 4, and I get 5, 4. So this function didn't go up at all, but what happened is that it shifted to the right. And if you compare your points, it went to the right 3. Okay, number 3. So now you need to have 2 times x squared. And when you plug this in the calculator, you also get 0, 0. But instead of 1, 1, I get 1, 2, and -1, 2. And then everything else is off the graph, so this is the best I got. And knowing the shape of a quadratic helps. So what happened is this actually got what we call stretched vertically. So if you imagine those arrows and you pull the quadratic up, it actually gets skinnier. Okay? So this is a vertical stretch. And we could say by 2 because that's the number in front. So if it was a 3, we would also say by 3. Now, it is important that you say the word vertical, though, because they're in upper level math classes, and even in this class, we also might see horizontal stretch too. So it's important to say which way. So if you had your parent and it gets skinnier, it's because you pulled it up. You stretched it out vertically. So what's going to happen if I do 1/2? Well, I also get 0, 0, but then I get 1 and then 0.5 and -1 and 0.5. I get 2, 2 and -2, 2. And then I get 3, 4.5. And I get -3, 4.5. So unlike the one we just did, this does not stretch. It actually gets wider. So we call this a vertical compression. So imagine taking the arrows of that red parent function graph and pushing them down, and it actually makes it like the two sides of my quadratic get wider. So we call this a vertical compression. Okay, and the last point, the last translation that we did not get to practice with is the one at the bottom. It says, remember, what does a negative do in front of the x squared? Well, that flips it vertically. So it would take any of these functions that you see, and instead of it opening up, just like we know it opens down. So we call this a vertical flip. And yes, we have horizontal flips, so you do need to say vertical. So this is an example of negative x squared. Okay, so if you go to the next page on the back, we have this table. So these are all the general rules. Okay, so notice that we don't just have plus k like we did on the front. We had plus 5. We also have minus. So it's important to know the difference. So if it's plus, just like we knew from the front of the worksheet, it is a shift up. Then if it's minus, it's going to be a shift down. So an example of a shift up would be like what we had, x squared, and then on the outside, I don't know, plus 4. And then an example of it shifting down would be x squared and then minus any number, so let's just say 10. And there's plenty of examples, I'm just giving you one. Now, on the front of the paper, when it said x minus 3 quantity squared, then that was actually a shift to the right. So when it says plus k inside like that, it's a shift left. Now, I'm going to star both of these because this is important to know. If you see plus with up or down, plus means up and down means negative, just like you would think. But with inside our x shift, any horizontal shift, left or right, it's actually backwards than what you think. Just like in vertex form, we've talked about this before. So just like in vertex form, you know, if I had x plus 4, that would be an h value of negative 4, which means we would go left. So when you see plus, it also means left. So an example of this, we could say x plus 4 quantity squared. And then a shift to the right would be any number, but with inside, it would, inside with x, it's going to be a negative. And then we know what this negative x does. It's a vertical flip. We already said that. And it honestly doesn't matter what it is. I could have negative x squared plus 5. I could have negative quantity x plus 1 squared. All we care about is this negative in front. So it doesn't matter if we have any other shift. If it's negative, it's a vertical flip. And lastly, when we have an a in front, a value of a, and it's not just negative, and I always teach that the negative and the value of a, so if a was 2, are two separate shifts. So if you have negative 2 in front, you have a vertical flip and you have a vertical stretch. So it's 2 shifts. So again, if a is greater than 1, that's the rule, then we have a vertical stretch. So an example of that would be, I don't know, let's say 3x, and we'll also shift it up 1, for example. And then if you can't have it, it can't be negative, because like I said, if it was negative, we would treat it as a separate shift. So any value that is less than 1 is going to be a vertical compression. So that would be like having 1/3 and then 1/3. And then I throw in, I don't know, a shift to the right 1. Okay. Now down here, these page numbers, since we're doing this together as a video, then this is just extra practice. So if you want some extra practice with it, go ahead. And if you have questions, bring it to me and we can go over it. Okay, so now we're going to put it all together. So the point of completing the square was to write it in vertex form. So that's the first step we need to do. We need to write this in vertex form. So first step is to kick out that 13. 2x squared plus 12x, and then I move plus 13. Now, since we have a value for a, it's 2, we need to factor that out. Sorry about that. We need to factor that out. 2 times x squared plus 6x plus 13. Okay. So now we're going to complete the square. So now we have a new b, which is 6. So 6 divided by 2 is 3. And then when you square this, you get 9. So I'm going to add 9 here, but this is where we say stop, think, what did you really add? And since I put it in parentheses that had a 2 in front, I really added 18, so that's what I need to subtract. So this simplifies to 2x plus 3 squared, and then minus 5. So before we do anything else, let's identify these shifts for practice. This is a vertical stretch. Since it says plus 3, this is a shift left 3, and this is down 5. So that makes my vertex -3, -5, and therefore my axis of symmetry is x equals -3. So if I were to plot this, I would have -3, -5, and then that's the only thing I have to plot. So honestly, you're going to put it in your calculator and then look at all the other points of what you should plot. So the next thing I got is -2, -3. So because there's symmetry through the vertex, I don't even need to look at my calculator. I also know I have the point -4, -3. And then I have the point -1, 3. And then again, because there's symmetry, I have the point -5, 3. So here it is. So I went down, left, and I stretched it so it's a little skinnier. Okay, so this next one, same thing. First thing we need to do is complete the square. So we have 2x squared plus 16x, and we move out plus 23. And I factor out the 2, and I have a new b, which is 8. So half of 8 is 4. Square that, you get 16. But I didn't really add 16. I really added in 32, which means I need to subtract 32. So my final answer is 2 times x plus 4, quantity squared, minus 9. And again, let's identify the shifts. This is another vertical stretch. This is left 4, and this is down 9. Now to graph it, the vertex is -4, -9, and therefore my axis of symmetry is x equals -4. Now to graph this, I'm actually going to have to count by 2's, so I'm going to write that up here to change my scale because I can't fit it with this stylus and this app, but you can write on there 2, 4, 6, 8, 10 and count that way. So that means I have -4, -9, which is right here. I have -2, -1. I have -6, -1. And then I have actually -1, 9, and then I have -7, 9. So again, it got skinny left and down. And it can do anything. These two just happen to be the same type of shifts. So what I want you to do right now is on that second page, you're doing the same exact thing. So you have letters A through F. I want you to do exactly what we did here. If you don't have to complete the square, you can just start with the vertex axis of symmetry, plot the vertex, and then you put it in your calculator and plot those points. But then you're also going to have to complete the square. Remember, if there's a negative, you have to factor it out, just like for these two examples, A and B, we factored out the 2. And then obviously if there is another 2 or another number in front, you have to factor that out as well. So take a look at the rest of that worksheet, complete the front and back, A through F, and then go on the portal and check out the answer key to see how you did.